because no, you haven't done it, right? Okay, you're up. Oh, I forgot. Yeah, I think we'll manage. Now, by the way, guys, I think we are a little one class behind because according to my schedule, we should be discussing like coding and programming. We should be doing methodology and approach. I think part of it has to do with the delay of class. So I feel that we are one class behind.ครับผมเข้าซูมแล้วแชร์เลยลูกครับผมเพื่อนไม่มาตั้งเยอะคราวที่แล้วโอเคขยายหน่อยลูกOkay, the suicide team, I'm sending you a paper right now. One of you should look at this. Suicide team ชื่ออะไรนะ นอนไม่นอน ตามเลยโทษตามเลย Okay. Start. Okay, guys, pay attention to your friend. ดัง
For our group, we will do like forecasting the bubble of economic crisis. So this is like a framework that we from this made by DataAnalytics. So we given out 7 factors and like the scenario given here. So 2007 was 2019, which is all the factors. So the first one is the high price relative to conditional maturity design is what the CPI and like the standard deviation. Yeah, so we use like the CPI standardization from normal price.
Okay, guys. The crisis that Dalio, the author that you're basing this on, is a debt crisis, right? Just a particular debt crisis, not a general economic crisis of any kind, right? Okay. And these are the factors in mind. And you are interested in replicating the study, creating a indicator. Okay. Do you have all the data set? Sorry, the data fields. Okay. How will you find that?
So I think this
okay, and how you how you going to get that?
I think
Wait, you didn't speak. You already spoke with me in line group, right? Yeah. Okay. How about you two? Okay. Of all the 7, right, indicator, are these specific indicator or it's a set of indicator? For example, is there a broad bullish sentiment? Now, as I understand, Dalio didn't give you the exact that, right?
so we have to
Okay. So a lot of this would be here's the thing though, if you were to do this right, then you have to make sure that the variable that you came up with, when you look at all the previous crises, you can check for those countries and you get the same yes, no, yes, no. Will you be able to do that? Not all of them, maybe all the US, maybe, I don't know.
I think like some will be like I don't think we cannot like because I think some data will,
yeah.
But I think we should be able to like tackle some of it.
What is the outcome? Now here's the difficulty, guys. If they try to predict a crisis, a crisis is it's not like default. If you're predicting a debt default, you certainly have a fixed horizon. Is this client going to default before he finishes paying his due, or is he likely to default over the next year or over the next 3 months? It's something very definite, right? Your target variable is a yes or no, right? With crisis, it is also yes and no. Is there going to be a crisis? Yes or no? But a crisis happening, it may have very different timeline, right? So even though your model is very good, but for some reason, you can't predict crisis in the year because it happens the year after. So predicting timing is going to be quite difficult. Let me ask you this. Do you want the outcome of your project to be predicting yes, no, or giving the amount, the time? Like, tell your friends.
Because like predicting years, like it's too hard. Even
Yeah. Okay. If you want to apply that to Thailand, unfortunately, crisis is one of those things where it only happens once in a while, right? So you can't say, for example, at the end of this project, you have a prediction model and you check against last year because we didn't have crisis last year. So you can't, you know what I mean? You can't really say, well, let's back in 2018 and predict 2019 and 2020 because the actual answer was no, right? And the previous to that, the answer is also no. So until you go back all the way to the 1997 crisis, all the training example would have been negative. Sorry, all the testing example would have been negative. So that's why I'm thinking, let's blend this exercise. By the way, this is not pattern regression, right? This is more like X various thing, right? And predicts Y, okay? So yeah, this is your objective. But my guess is that in order to make this project worthwhile, and there's no way you can test this, like wait another 2 years or previous 2 years, maybe you can kind of create an indicator and you can track the vulnerability. So instead of prediction, it be some kind of vulnerability indicator. And then you can say, you can look at some of the countries. Let's say you pick United States 2000. Yeah? You can say that this is when the crisis happened. You can say that this indicator that you created keeps going up. Right? Then you look at Japan, 1989. The crisis happens here, and the indicator goes up. Then, in terms of Thailand, you can say, this is Thailand. Are we doing this? Or are we doing this? Or are we doing this? Then that's good enough, because you don't have to say, what happened to Thailand? You see what I mean? So you're kind of validating index. Right? And then creating a dashboard. So it's a validation plus some kind of a dashboard building. Say for Thailand right now, where are we? That's why in the conversation we had on Saturday, I mentioned you should look at things like doomsday clock. Yeah? You guys know what a doomsday clock is, right? That's like saying that if the scientists and the political scientists and climate scientists, they all study the global risk in humanity. And, on a scale of 1 hour, how close we are to doomsday. We are about 100 seconds away. Yeah? It used to be higher when we were having the middle of the Cold War, Cuban Missile Crisis. You can Google right now how close to the doomsday spot during the Cuban Missile Crisis. Okay? So you can create that kind of thing.
You say that the date of the happen like during something like this, like during the office topic?
It's not quite, because you're actually just saying that, in order for the crisis to happen, this thing goes up, right? But for 1989 Japan, it may go up like this. For 2008 US or whatever, it may go up like that. So it's not able to give you prediction the timing exactly. You know, like it's not like once this goes over 0.5, then it's a crisis. I don't think you're going to get that. But what you want to do is to get the confirmation that yes, before the crisis, you get upward trend in something. That's all you need. If you can verify that for all this past, and then for Thailand, are we seeing this or this or this? That's good, right? So that means you don't have to get to the actual timing, because people that can't do that prediction. Yeah. Basically, yeah. It's you have to verify first that for all this thing, the index that you create goes up, right? Prior to crisis. And then you just look at a new country. Doesn't have to be Thailand, doesn't have to be anything. And then you can look at Thailand before 1997. Okay, you can do something like that. But to make a prediction like it has to hit 50, then something happened in the next 5 years, I think that's going to be very difficult to get. Yeah, it's very, crisis is a once in a lifetime kind of thing. Yeah. We'll see. It's going to be hard. But I think something like this, verifying that you have indicator, a set of indicator that together moves upward prior to event. And this is what medical people do. Before people, you know, the disease becomes serious, you have the vital sign. Except in medical in medical diagnostics, it's very simple. It's very obvious. You know, if your blood sugar goes up or something, it's certainly bad. Whereas with this, you don't know if it's bad or not. Okay, so you want to get that creation, and you may be able to say how much is number 3 more important than number 7. You see what I mean? You can do this and say that, well, in all the cases, number 3 goes up. But in some of the cases, number 7 goes up, 7 goes down. So you can't really rely on number 7, right? It's not very good because sometimes it goes up and it doesn't do anything. But certainly number 3 is always like this prior to crisis. Then you can say, aha, this guy's really important. Yeah. So for them, they said, so the conclusion from the author is just saying this is a factor that yes, if this happens, but you are looking for something more deeper. You're looking at trend. Yeah. So you can imagine, okay, this could be artificial, but let's say number 3, some kind of number. Is it yes or no? Yes, but it actually been on a declining. So it's yes, but it actually been declining. So it's not a very good indicator, for example. Yeah. So you can say a debt, government debt ratio to tax revenue. Okay, was it negative? Yes, but it actually was a lot more negative prior, and nothing happened. So that's not good, right? So you will be able to verify this in a time series, in a temporal kind of way. And I think this is good. This is going to be even better than the conclusion we get this test. Okay, but you're going to have to do a lot of constructing the index and test and all that. But Bank of Thailand has very good data set. Oh. Okay, it's team 3 ยอด, right? 3 ยอด, that's doing the. I thought the defect was the kaleidoscope. Okay. Oh, movie. Gotcha. โอเคครับ โอเค come Moneyball, right? Moneyball. Who hasn't spoken? I know. You spoke last time?
No, I didn't.
Okay, so good.
So just to recap on what we did last time. So our team will use the machine learning to select the best team, the starting team, the lineup for the football game.
Okay. So these guys are looking at the FIFA database. They have characteristic of each player, like we have in video games, attributes of players. Okay. And they try to put a very good, as we understand, last time there were two approach, right? One is to formulate it as a constraint optimization. You can't just put all the best people in the world in the team because it's too expensive, right? But the other thing is more like what?
Like just do the machine learning for
exactly. When who faces who and what strength and so forth. And I think that's what we decided to do. Okay, good. So tell your friends what we kind of discussed and what you've done since Wednesday.
And so after last week, we did research on many articles and research. We found that this research already exists in the market. However, the outcome or the output of the learning in the research isn't what we're looking for. It's just for example, this research, the outcome is just the average
stat
players by combining and the average of attributes.
Okay, can you send that picture online later? Yeah. Okay, so the target variable is not the same.
Yes.
But does it mean that you cannot use the input variable?
No, we can still use the variable we got.
Good.
But we want to do further than this, which is that we think that we will go further to more in the tactic area.
Good.
Like in the game, right? Every team needs to have the tactic. Mm-hmm. So when choosing players to be in the lineup or in the squad, tactic and the players need to go together.
Good.
So, for example, like there is a tactic that they will use long ball to attack the opponent. With that, we may not need the best, like the one that the best system, but we need
the English Premier, I think they usually do that. It's not Brazilian style. Okay, so it's a really English style football, say. Okay, good. Right. So.
And so right now we're trying to find the database for the tactic. So right now we haven't found the one that accurate or having in the or like the generated data in the Excel file. So I think if we can't find that one, we may need to do it ourselves.
Okay.
So
you guys hear that? So it's not always trying to find the right data set. So you just have to make it sometime. For whatever your purpose. You might have to say read newspaper and say, they say Liverpool is this kind of style, so you put that as Liverpool plays like this.
So right now we find the instructions of each tactic in the website online.
Okay.
And we see that the common in common tactics, like
in the instruction, this one is use the balance tactic, meaning that they will not go much too much on attacking, but they are or too much on defending. They'll kind of like in the middle. Yeah, so we use this research what we found, and then we will put it in the Excel for each tactic.
Okay, your project is interesting enough, but I'll tell you how we would do this professionally. Okay, because a lot of this field is descriptive, and you find in the website that has commentaries, post-game analysis. The most obvious tool to apply would be NLP, natural language processing, where you harvest the news article, what happened when this team met with that team, and what tactic prevailed, and then extract from that as an input to your thing. Okay, but because your analysis, I think, is quite interesting on its own, just using statistic and trying to match the tactics and all that. And also, we haven't really gone into NLP, and that's a big topic on its own. So I would say that if you were to like create a real, software consultancy house out of this, you would need a large component of NLP as a pre-processing or information extraction. Okay, but for this, I just mentioned that, yeah, that's something you will probably need. But for now, if you can do hand annotation, by all means. Okay, so that's my comment. Good. Now, so let's say you are able to do this kind of thing, some kind of team tactics. Now, are you going to be able to map tactics with players? Is it obvious? For example, something is obvious, like if you dribble well, then you're very good for certain tactics. So is this mapping clearly defined, or you have to create as well? Like if I have something like a tactics and I have a player characteristic, can I say right away that this characteristic is good for this tactics? Is that an obvious thing?
It's not that obvious because like in the game there's something about the team chemistry.
Oh yeah.
And how like the team works. This player works with this player.
Okay, so no, but that's another effect. That's about interpersonal, right?
Yes. Okay,
they may like each other. They may both come from Brazil, so they like each other, or maybe they both come from Brazil, so they compete with each other. Okay, but I'm talking about actual performance. The dribbling, and the tactics. Can you get an exact map thing from this is good for that?
Yes.
You can. Okay, so even if it's not universal truth, you can create like a lookup table on your own for this purpose. Okay, this may have to be validated later. But for this shot, let's just skip this step and say you come up with a good table that say if you're good at dribbling, you're good at passing, you're good at stealing balls, you're good for this tactics, something like that. Okay, so maybe you can do that. Good. And it's going to be machine learning based rather than optimization based analysis, correct? Right? And then the interesting part is to say, now that we know we're going to face this guy on Sunday, right? I can try different combinations to see which one has the best success rate. It's the pseudo inverse. Okay? I want you guys to take this problem, by the way, is extremely interesting because it ties two things together. Optimization means what's the best X that gets you the best Y? Right? What's the X that's going to get you the best Y? Machine learning says, give me an X, I'll predict the Y. Their problem would be, if I know enough relationship between X and Y, machine learning based, and come Sunday, my Y is to beat this team. What is the X? Now, it's an optimization problem, but it's not done using optimization tool. It's done by trying different combinations of the X to see which one gets you the best Y. It's the pseudo inverse. So I want you to really emphasize also this part of pseudo inverse. Okay, it's very interesting. You have a lot. That's what that's why I don't think you should bother with NLP because that's a whole big thing. What you got is already complex. Okay, So we have individual players, right? And you also have to have actual records of previous matches and who plays on which match, right? Maybe you don't need to go, in substitution. That's a little bit too much. But certainly you can do something like composite of team attributes versus tactic versus this. Okay, so my shorthand, my mental shorthand for your team is to say it's a cobweb game, right? So you have multi-dimensional aspect of the player. This cobweb meets that cobweb. Okay, and so you get this cobweb comes on Sunday. Which cobweb do you choose to meet that cobweb? Okay, good. And yeah, it looks very interesting problem. Again, when again, I'm quite proud to say this, that I was the one who introduced the concept of interconnectivity to data analytics in Thailand long before social network became a thing. But I use it for banking interaction between financial institutions. My matrix of connectivity between banks, I use what's called eigenvector centrality. But the first problem that I tried on was on football, was the network of who beats whom in the previous. So in other words, if you look at the previous league you saw, right, you get up with the final table of the score, right? You get 3 for wins, you get 1 for tie, you get 0 for loss, right? But that doesn't tell you the story, because are you winning against strong opponent or winning against weak opponent? So this is kind of matrix relationship. Yeah. So I use that kind of matrix relationship to model financial institution. Are you borrowing from this institution or are you borrowing from that institution? Yeah. If you borrow from institution that borrow a lot, or you borrow from institution that has its own liquidity wealth or something like that. So it's not just how much, it's to whom. Yeah. So football is a very intricate problem. So even though it's a game, it does give you a way of formulating very interesting aspects. Yeah, good. Formula 1 is another thing. Formula 1 has a lot of track statistics and real-time statistics of what happens. How many times does this guy come up and overtake successfully, doesn't end up in a crash?
So if we have all data on hand, so if you want to start doing developing the learning, so how should we start?
Yeah, I think for all practical purpose, I think Wednesday I'm going to talk neural network model, because that's going to come in very handy. Okay, so let's do another switch or whatever I plan on Wednesday. It's going to be put on hold. It's going to be multi-layer conceptron. Okay. Oh yeah, we can do that in balance. Okay, so Wednesday, I think for this team and also for the other team that need the effects or something like that, with the spectral information, I think what I'm going to do is on Wednesday we might cover the project a little bit, but I'll spend a lot of time on lecture. Okay, I think, yeah. So it's basically how pattern feeds pattern. Okay, good job. Okay, you're up. Come on. Okay, you go. Sip คนได้ A 9 คนได้ B ฮะ Go.ได้ยังครับ โอเค go เอ้ยคนนี้นั่งเก่าดีกว่าอ๋อโอเคทำไมผมโอเคเล่าGood. You have harvested the data, the 1,000. Okay. That harvest. And that ที่ว่ายากใช่ไหมที่ว่า Okay. Okay, fine. Your TA is helping with that, but worst come to worst, you just use your fingers, right? 100 times or that. Okay. Okay, go on. Okay. guys, they're looking at pictures from Facebook, right? And the Facebook post has one or more pictures, and each post will elicit response in terms of number of smile or I don't know, not retweet or whatever, sharing or whatever. Okay, so these are all metrics of engagement. Okay, so there are multiple targets that do that. They can create a positive index and an overall engagement if they want, whatever. But the point is that input is picture. Now the picture would then have to go through what I think we have to learn on Wednesday, which is image classification. Now the more interesting, but I don't think you can get to at this point, you may not be able to get to, is to get to annotation. Picture of a girl holding a cup of coffee. Okay? Right? Or dog chasing a cat, or cat chasing a dog. Okay? Those have different meanings. But I think for that purpose, that might be a little bit difficult. So it might be just picture of cat on dog. At this stage. Okay? At this stage. Right? Get that? Again. Picture of a dog chasing a cat and picture of a cat chasing a dog certainly are going to elicit different response. Right? One is a lot more surprising. But for our purpose, let's just say if you can identify one cat and one dog in this picture, it's considered the same. Yeah? And based on that, so you need a neural network to do object identification, right? And then the neural network to take that object list of objects and predict something, predict engagement. Okay? And the second part may not be a neural network, but the first part certainly will have to be a neural network. The second part will be some other thing. Let's just say I want you to split your effort. Certainly there's going to be a lot of programming effort right now trying to get a picture. But I don't want all of you to spend the next few days doing that. You should start looking at things like, again, forward prediction. Okay? How can you predict something for social engagement? What kind of variable is it? Ordinal, nominal? Can you put them into a composite? Okay? Right? And based on that, so maybe I would say two-thirds you, maybe 4 of you would sort of like proceed, assuming the other two figure out how to download it. You know what I mean? Right? So you don't wait. You just assume it's doable. And it is doable. It's either doable with the program or doable with your figures. Yeah? It's okay. I've downloaded thousands of paper by hand and renamed it, so it's not that bad. Yeah, sometimes it comes to that. So let's say you have pictures. Now, the pictures, if you download by hand, by the way, I was going to say, because each course has more than one picture. Let's just focus on the first picture. Yeah? That's hard enough. So again, I'm not interested in final accuracy. So a lot of these steps may be a little bit silly or not sensible. You just need to know. For now, we don't have the resource, or we don't have the ability to do all this. Okay? We'll leave it to later version. Yeah? So for the prototyping, just take the first picture and social engagement metrics. Now, social engagement metrics, let me bring it up again on the board and see where we've got on Facebook. Is it public, right? This is public. Or do you have to do a public? Okay. So what kind of information you get? Number of reaction, number of comment, number of share, number of like. That's good. Number of love, number of wow, number of okay. So good. So good. So these are all what? These are all counts, basically, right? Now, here's the thing, though. Something I want you to think about. We haven't talked so much about target variable because we usually assume there's a y you want. But in this case, what's the y you want? Yeah, the naive way would be to say there are 1, 2, 3, 4, 5, 6, 7, 8, 9 different y's, and you're creating 9 different problems. That's the obvious thing, right? There are 9 outputs, so you're doing 9 prediction problems. But certainly there's something more to it. There is such thing as of this 9. Okay, one is this thing is about volume. So it doesn't matter if it's positive or negative, but this one would have to do with sentiment. There's a plus minus to it. Okay. And also because these are all counts. These are all counts. Okay? You are interested in actual count or shape. In other words, especially here, okay, if you have something like this distribution, you want to distinguish this from, say, this distribution. That's distinguishing in shape in the distribution. But you also say this is also different from this. So it's a similar shape, but a lot more. So likewise, you're interested in volume or in the shape. So all these things you have to start thinking about. Yeah. Now, in a lot of machine learning class or any difficult class, you barely ever give a thought about why. Usually, you spend a lot of time cooking up the x because you want to predict why. Why is obvious, but as you see from time and time again, why is not obvious. Like the suicide people, right? Why is not just the number of suicide, but suicide per country, yeah? Or hospital bed. You're not predicting hospital bed, or you're predicting hospital bed as a percentage of available, yeah? And all kinds of stuff. So your why should be a lot more complicated. Most of the time it's a scalar, and in fact when I teach you on Wednesday about machine learning, most of the time we'll assume that the y you're trying to learn is a scalar, it's just something, either classification or a number. But this thing, you actually get a vector, you get, it's a different kind of information. So even if you have all the x's, you still have different kind of problems to solve, right? And you try them all, and you see, you can't really use this x to predict the number of response, but we can predict the balance. Is it more or less? More positive or less? So maybe you can predict the total. Alternatively, you can say, I can't predict the total, but I can predict the volume. Okay? So you try different y's, and based on success or failure. Again, I'm not after a single accuracy number, right? The job is not to say, give me a volume prediction model. That's not what I'm trying to do. Okay? Data analytics is more general than that. So you can say, I've done all my best. It's impossible to predict volume, but I can predict sentiment, vice versa. Okay? Give a good thought on this, all of you. But certainly in terms of projects, you can say that 2 of you or 3 of you are left behind trying to download the picture, and the rest of you trying to say, if you got the picture, how can we go forward? Yeah. Maybe I should have covered neural network today instead of Wednesday, but well, never mind. Okay. So, okay. And status. Okay. So how will we do? I want each team to just briefly, one sentence, tell me what is your activity over next week. Very quickly. Okay. Team you what's your team? Shield. What is your 5 days activities? Next, what are you going to do? tomorrow, Wednesday, Thursday, Friday. Okay, you have to find, no, not just the formula. Your is the prices, that prices, right? So the 7 of them will be different for different countries. So at the very minimum, next week, you should be able to give, I can say, you know, for USA crisis 2007, criteria number 3, you should be able to give me exactly what the data is, okay, that you are going to be using, okay? You don't have that. It's like I said in the conversation, if this was an academic paper by Dalio, he would be obligated to give you the source. Now they're trying to follow the publication by this guy who is part of a private consultancy. So he's giving the result, but it's not giving you where the data came from. In fact, you know, this would not get published in academic because you can't verify the truth. You just have to believe him, okay? In scientific research, you have to be able to, in theory, replicate every result because there's a source of data, there's a methodology. If you ran with the same data or the same methodology, you should get the same exact result, okay? You can't do that with this guy, this paper. So that's a little bit unfortunate. But because you like the organization or the approach, you're sticking with it. It's fine. That means you have to come up with your own data. So when you say the public sentiment of Japan 1989, you have to come up with your own series of public sentiment in Japan. That makes sense. Okay? So I expect you to have all this, all the countries and all the 1, 2, 3, 4, 5, 6, 7 at least, right? And maybe if you have your own imagination, maybe you have number 8. Fine, right? But at the very minimum, that table should be filled with at least the source. And if you preferably have already harvested or downloaded the data, clean the data, that'd be good. Okay? So get that data done in 5 days. Okay? In that sense. Okay. What is you guys? No. Kaleidoscope. Okay, Kaleidoscope. What is your 5 days life plan? 3 sentences. Okay. Awesome, right? No. Movie. Okay. No, I don't want you to say that. I want you to say something like, you would look at the database and maybe you do a visualization or you do a histogram of all the fields. Okay. So that at least you will understand where the data is, right? Then you would also go back to lecture, I don't remember which number it is, unsupervised learning, right? What did we learn? 2 things. We have the mathematical node, cluster analysis, and dimensionality reduction. Right? Cluster analysis and dimensionality. Those will become very handy. Okay? And you can start to see if you can get to the programming thing. Okay? If you're going to use mathematics, you can ask me about it. If you're going to use Python, you try to learn cluster algorithm. Very, very clustering. Okay? So, yeah, I'll just say, so you would have to see where the data gives you, what the data gives you, what kind of distribution, right? A lot of times you will work with categorical data, so it will be a histogram, you just have names of things like country, okay? Yep. Good. So focus. I think a lot of your thing would be a lot of unsupervised learning, right? I think. You guys, simple, nominal, right? Okay. What's your 5 days action plan? team to start thinking about it. I would say you should focus on the variable set with the suicide thing, right? Right? Again, the global happiness thing, yeah, and I did separate the two parts, right? So part of it would really have to do that survey of global national happiness, the quality of life index, and see if we have all this for the data for the country that we requested. And the other group would be to look at the paper that I sent you, okay, and think along that line. Okay, countries that are close together and countries that are far apart. Okay, and you can say close to Thailand, far from Thailand. That's what you want. Okay, but certainly not to say, oh, Thailand and South Africa are too far apart. Okay, see that they are far apart in that socio-economic development. Okay, and so come up with that. So I would imagine that we should be studying maybe about 10 countries, right? In the United States. Okay, expand a little bit. Okay, Moneyball, action plan. Okay. Okay. Fine. Okay. But again, don't spend a lot of time on this tactics annotation. Okay. Just come up with something that makes sense, because you already have a very good database of player characteristics. You already have the cobweb, so to speak. You see what I mean? So even without the tactics mapping onto tactics, which I think is great, even without that, this cobweb to cobweb combat is already a very good thing. Okay? So try to progress with that. Okay, and Wang, right? What's your action plan? 5 days? Okay. Okay. Okay, good. Extracted photo. Yeah, I'll have basic photo. Yeah, you can leave a little bit because we didn't take any break. But okay, assignment, guys. Assignment. I'm going to be sending you in the group line an example of, say, one academic paper and a synopsis template, meaning sort of items that I put in. Synopsis is a little bit, it's a conclusion, it's a summary, okay? But in this case, it's a technical summary. So there would be a certain area like, okay, the name, obviously, the name of the authors, the title of the paper, the publication, and all that information. That's just to say what the paper is, right? And then the key point is this: what is the paper trying to do? With what data and what methodology and what conclusion? And the synopsis is going to have some optional items. I'll be sending you the example, so I'm not writing it. Yeah, there'll be something like, what is unique about this paper? What is it doing that previous paper didn't do? What is the gap? Okay, so it's not just a problem, methodology, experiment, conclusion type thing, but it's also more subtle to that. What is the unique contribution? Okay? Now, it would be really nice if you have some kind of feel that because of this paper, it's a landmark paper, it's a seminal paper, based on this paper, everything else came afterward. But that's sort of like putting the paper in context. That's a little bit difficult. Okay? Or this paper was the turning point from old style of AI, new style of data-driven AI. You know, this kind of commentary, this kind of deep meta-analysis. If you have that, that'd be great, but I'm not looking for it. Okay? I'm looking for what's just in the paper. What's just in the paper. And also in the paper, one thing that you don't really do, which I do a lot, and I suggest you do as well, is to look at the bibliography. Because the paper has its own peer, has its own reference, has its own difference. Sometimes I start using this paper as a basis of my study, but by the time I look at the bibliography paper, I go and look at some other paper. 5 more, 10 more. Okay? And that gives me a certain idea. Paper is a finished product. Guys, remember this. Paper is a finished product. It's not giving you a how-to on a general content. But paper are better than textbook precisely because it gives you a taste, an understanding of what happened when methodology beats real problem. So this picture that I was drawing earlier, method or math and problem, right? If you learn from a textbook, you learn the method, and then you go out to apply to a problem. With paper, you get the whole thing, the problem and the methodology. You can extract what's similar to your problem, you can extract what's similar for your methodology. For that problem, for that defect detection, the problem is not your thing, right? The paper that I send you, the problem is about yield prediction. It's nothing to do with defect detection. But by learning of spectral information, you can predict crop yield. Likewise, by learning from spectral information, you can predict defect because it shows up in polarized discoloration. Okay? So that's why paper is really your. I still go back to books, and you should start with books. Okay? That's why I'm writing this interactive textbook on machine learning for data analytics. But in real life, when you proceed, you should have read all the basic books. When you come to a new problem, you try to say, what shall we do with this? The first thing to do is literature survey, and I mean paper. Okay? So paper reading is basically the most fundamental part of being a data scientist. Okay? You can't reinvent things. You also cannot copy exactly what this guy did, because he's applying this aspect to that problem. You are trying to solve a different problem, or maybe a similar problem, a different context. So you can never copy exactly. It's never, let's do exactly what this paper did, but substitute their CSV data file with my CSV data file. That's never going to work. Yeah? But there will be a degree of likeness. Sometimes you can just get the data transformation from this paper. Sometimes you get the whole machine learning tools from this paper. Right? Sometimes you just get insight as to how to get the data and how to treat the data. In the old days, sometimes you would just write to the author and say, can I have the data? The data that you did for this paper, can I have it so I can run my thing? Yeah. Nowadays you go to GitHub and solve it. Okay. So I'm going to send you maybe tomorrow, maybe at the end of this, the example synopsis. I want you to have that synopsis done in 1 week, so Monday. If you want. Yeah. This will be again individual exercise, but the focus of the paper has to be for that project. So for this team, for example, the final project write-up, you would have at the very minimum 6 papers that gives you the methodology or the insight or whatever. And each of you would be writing the review. Okay? So it is an individual exercise. Nobody would, the team will have different paper, right? You won't be working on the same paper, but they will be all contributing to the project. Okay? That's it. Remember, I had an exercise where you were pitching the project, and those was a little bit incoherent, right? You can have totally different ideas. That was when we were doing the brainstorm. But now you're focused. Now you can't just do anything. You have to do the one that the paper is. Now I gave two paper in line, so those two are already chosen to have seen, but you have to find another paper. Okay? And if I come across any paper in my own database or internet search, I might just drop in. Okay? I may not remember which team is doing what exactly when I drop that. Okay? But you guys know which is relevant. You guys know what's relevant. So I'll give you the template in Word so you can fill it, type in. Okay? Sometimes you can put in a little bit picture, like scan, do an image capture of the key equation. I don't want you to have to write the equation fresh. Okay? So you can do like a Photoshop caption of the PDF file, cut to the equation that matters, the critical equation. So that will be on Monday. Okay? So Wednesday, even though Wednesday is only 2 days away, I want you to report to me as if you have done that 5 days that I have. Okay? So your 5 days, I didn't write them down, so I trust that you remember what you said. Okay? So in 2 days, the progress is along exactly what you committed. Not a general study of the paper. This is yeah. I was gonna say, can you do the synopsis in 2 days, but that's probably too much. Monday. Yeah. No, Monday, no. It'd be nice if you could read like by Wednesday. You know? Well, how about this? Try to read the paper by Wednesday. Okay? Try to find the paper, read the paper by Wednesday, but the synopsis is due on Monday. On Wednesday. No, it'll be too late because you need that for your project. I really wanted you to remember. I wanted you to have this synopsis, this paper read by today, but for some reason. Sorry. One paper per person. Yeah. It's what? No. Guys. Whoa. No, not the paper I sent you. That is just for one guy in one team to pick up. You find your own paper. Okay? I just found two papers that are definitely good, so I gave it as a freebie. So for the team, right? And the team, nominal, I think it was. Is it nominal? Yeah. So I gave two papers in the line channel. That is only for one person in one team. I don't know who that is. Okay? Okay? One guy, one girl, whatever, one paper. So everybody comes up with their different paper. Yeah. Okay? Individual exercise, individual paper, but pertaining to your project. You have to talk to each other. You know, the best thing for you, and I don't know if you would do this, but I would love it if you could do this. You should actually try to find 2 or 3 papers. Come together. Guys, listen. I would prefer if you do this, but if you don't do it, I wouldn't be able to tell. You should be able to come up with 2 or 3 papers that you think is relevant to your project. Bring them to the group discussion, prioritize them, pick among yourself. Which one are you going to focus on? And then 1, 2, 3, 4, 5, 6. So you should actually have a list of maybe 20 papers, and you have 2 hours together discussing this preliminary, what the paper is all about, and then came to the final list of 6. And then you write one, you write one, you write one, you write one. That'd be good. Synopsis. Yeah, one person, one synopsis, one paper. Different purpose, different synopsis, different paper. Article, paper, yeah. Yeah, paper, article. No, you don't have to even know that. Okay? But focus on the team project. Okay? On Monday. Make life too easy. Okay, if I have time, maybe. Okay, I don't promise. But how many teams do we have? 7, right? Okay. Yeah, I'll think about it. Okay, so I might do that. But it's easy, guys. You can do Google. You know, when I was your age, I had to go to a library, go to drawers, and get out a piece of paper and tell me which book and which article. And if I want to read article, I have to go to a compendium of an annual bulletin of what's published that year and look at, oh, in August, there's an article written in Monday. And then I have it. So life's much easier already for you guys. Okay? Okay, so let's do that. So on Wednesday, final thing. Try to make up your mind about your programming platform. I strongly encourage mathematics. I usually have to fork out 100 lines. Okay, but it's a lot easier in life. Okay, but we can discuss that when we talk about the pipeline. Okay. So let's call it a day, and we'll see you on Wednesday. Nothing should happen. Okay,ครับผม